Hey everyone, today's video is on dilations on the coordinate plane, and this takes dilations that we did yesterday and puts them, like it says, on the coordinate plane. So we're going to actually deal with certain points on the coordinate plane. And again, I'll refer to the box right at the top of your note packet. It says a dilation around the origin on the coordinate plane is performed by multiplying each coordinate of the vertices by the scale factor, which is usually signified with an R. Okay? And I'm going to underline this part right here. You multiply each coordinate. That means your X and your Y values are each multiplied by the scale factor. Alright? So let's dive into the first exercise here. I've got part of the coordinate plane on your screen here, really the only part that we need to see to do the problem. And I'm going to label these points to begin with. Alright, let me switch over to red, so this will show up on my blue coordinate plane that I have here. Alright, and this point right here is simply the point 0, 0. So I'm going to put in here that is 0, 0. This point, which I'll label B, is the point 2, 3. Alright, so hopefully that is pretty straightforward for everybody. And I'm also going to write them over here. This is 0, 0, and B is the point 2, 3. And the question asks us to do a dilation, dilate the line segment with a scale factor of R equals 3. Alright, well, if I just follow my directions right up here in the box, it says you take each of the coordinates and multiply them by the scale factor. So I'm going to come up with an A prime and a B prime, and all I have to do is simply multiply each of these numbers by 3. So 0 times 3 is 0, and 0 times 3 again is 0. So that was pretty straightforward. Well, A and A prime are the same point. Alright, well, I'm going to do the same thing with 2, 3, and again I'm going to multiply by 3, and I'm going to get 6, 9. So I can go over here, and maybe I'll switch over to green to draw this one in. I can graph this set of points right here, which is the image of my original line segment. Alright, so A is going to also be at, or A prime is going to also be at 0, 0, and B prime is going to be at 6, 9. So 1, 2, 3, 4, 5, 6, and up to 9 is going to be right there. Okay, this is going to be B prime. That is 6, 9. If I can draw a straight line with this, it will be pretty cool. Yeah, that's not too bad. Alright, so you can see the scale factor of R equals 3. Well, it basically took this line segment and made it 3 times the length of the original. So not really too difficult so far. Okay, let me turn this one off, and let me put this next one on that you have for exercise 2. And I'm going to switch back to red so it shows up a little better. And I'm going to do the same thing. I want to dilate this triangle with a scale factor of R equals 4. Well, let's label these points to begin with. And again, we're going to label it A, B, and C. So I'll go over here and I'll just list the coordinates for A, B, and C. Let's see, this one looks to be at -2, 2. B seems to be at 1, 5. And C seems to be at 3, 2. Alrighty, and I want to do a dilation on these with a scale factor of 4. So I do the same thing. I take each one of these points and I multiply the X value by 4, and I multiply the Y value by 4. So I'm going to get an A prime that is going to be at, what's -2 times 4? That's -8, 8, and B prime, which is at 4, comma 20. And point C is going to turn into C prime, and if I multiply by 4, I get 12, comma 8. Alright, now these are going to be pretty easy for you to graph, although one of them, actually two of them, these two won't fit on the coordinate plane that we have here. So the more important thing when we do the dilations, I know with the reflections and the translations and the rotations, we've kept everything within this 10 by 10 grid. Alright, actually 20 by 20 grid if you go all 4 quadrants. We've kept everything on the grid, but with the dilations, because as soon as you start multiplying by 3 or 4 or 5 or 6, etc., they get really big really fast. The more important thing is that you list these points out and that you have them each correctly multiplied by that scale factor. Okay? Okay, let's finish up with exercise 3, and this works the exact same way. I'm going to label these 4 points. Let's label this one A and this one B. And we'll just go right around the figure here and make that D and C. Alright, so I'm going to write the coordinates of the 4 points right over here. And let's see, A is at -2, comma 3. And looks like B is at 4, comma 3. And C looks like that's at 2, comma -3. And D is at -4, comma -3. Alright, and this one asks us to do a scale factor of 2.5. So we do the same thing for each of these points. We simply multiply the x and the y by 2.5. Alright, and we're big boys and girls. We can multiply by decimals. If we have to get a calculator out, we do that. And I'm not going to take 15 minutes to show you the calculations of each of these. I'm going to go ahead and calculate them and put them up here for you. Okay, so there's all the points. Again, I simply took each one of these x and y values and multiplied by 2.5. You need to be careful of your positives and negatives here. And notice I have those in as well. And again, it gets very big, very fast. This one can fit on the coordinate plane, so I'm going to go ahead and graph that. Okay, so there's the parallelogram is what we have here. There's the parallelogram dilated with a scale factor 2.5, and you can see as it made it much bigger, but it did fit on the coordinate plane, so I wanted to get it on there for you. And notice that a dilation keeps the same shape, but not necessarily the same size. So these two parallelograms are similar. Alright, that's about it for tonight. I hope you have a good night. Thanks for watching, and we'll see you tomorrow.